Hello viewers, this is Supreme Education Foundation Schools Year 11 Mathematics class. Our very first topic this Trinity term is Introduction to Probability. My name is Mr. Ayodeji Ogunyeye, and I'll be your tutor for today. Introducing probability. Our objectives are using words and ideas of probability, and also understanding and using the probability scale. So students, you are welcome to class today. Let's get right to it. How do we measure the chance or likelihood of something happening? We said our topic is probability. Please take note that probability can also be called chance. So when you hear the chance, we can also call it likelihood, okay? We can also call it likelihood, probability. So let me just say probability or chance or likelihood of something happening, okay? But commonly in our topic, we will use more of the word probability, okay? And we'll use more of the word chance. Just a few times we might want to use the word likelihood, but take note that probability and the word chance will come up a lot of times in this topic. Okay. We can use a line that is called a probability scale to express probability. For instance, if you look at the scale that I have here, to my extreme left is what we call impossible, when something is impossible to happen. Okay, some things never happen, they are just impossible. To the extreme right, you have some things always happen. They are certain that they will happen. In the middle of my scale, right here, we have what is called even chance. Some things are just as likely to happen as not to happen. It's an even chance. Or we simply say a 50-50. Now, this simply means that they have equal chances of happening, okay? It's either it happens or it doesn't happen equally. It doesn't happen equally. Now, when you have on your scale, in between impossible and even chance, you will see that you are saying that it's not 50-50 and it's also not impossible. So we just use the word unlikely to denote that. Some things probably won't happen, but it just might. So we use the word unlikely to express that. Also, in between even chance and certain means that it's not certain, and it's not a 50-50, but it's just close to certain. We use the word likely, because some things probably will happen, but we can't even say they might not even happen either, so they may not. So we use the word likely if it is, you know, closer to the fact that it may happen. We use the word likely, but it's not certain. All right. I want us to place the following events on the probability scale, just to see how the probability scale works. Here, the statement here, or the event that we are dealing with here, which we want you to place on this probability scale, is the event of you celebrating your 200th birthday tomorrow. Students, is any one of you turning 200 tomorrow? Of course not. Even if you are going to live up to 200 years, you cannot be 200 tomorrow. So definitely this event is impossible. So this is the correct place to put this, your pointer on your probability scale. So just like I said as well, if you do live up to 200, it's not your 200th birthday tomorrow. So it's impossible that you will celebrate your 200th birthday tomorrow. Now here we have a coin. We'll just have a diagram of coins there. If you toss a coin, you will get heads. Now what they are talking about here, since we are new to probability, is simply that when it comes to a coin, two things are always possible to happen: head or tail. Now, don't be confused when you saw the word tail, okay? What we just mean is that when you see the coin, for example, look at this coin right here. You can see that the face or the side of this coin or the face of this coin, which we are looking at right now, even this one over here, is showing the head on the coin. So there is one side of the coin is called head because it has the head on it. Then the other side, like this one here, you can see the other side, okay? Because we already use head to represent the side of the coin that has the head on it, we just call the other side the tail. So this, for example, okay? This, for example, this is head, okay? But over here, this one, and which one should I pick again? Let me pick this as well. I can even pick these guys here. So all those guys that you're looking at, these ones definitely are the heads. That is just to let you get familiar with the words we use when it comes to a coin. And also, these guys here are definitely tails. So don't be confused, okay, when we talk about heads and tails. All right. So I believe that is understood. Clear drawings. Now, so because we know that a coin will always have a head or a tail, okay, when you toss the coin. Now, the event here is for you to get heads when you toss those coins. Of course, definitely, when you toss a coin, it's either it lands on the head side or it lands on the tail side. So which means definitely on the probability scale, it's going to be an even chance, okay? They are equally likely, okay, to happen. So for you to get heads, it's an even chance, all right? Okay, this is the correct place and it's equally likely that you get heads as tails, just as I've explained. Now, it will rain in Madrid on the 15th of August. I'm sure you're going to have to need to know more about Madrid and know about the weather over there. Definitely in Madrid, on the 15th of August, definitely, it's not impossible for rain to happen, but it's just kind of unlikely, you know? So we put the pointer somewhere here on the probability scale. Okay, you know, it's not exactly unlikely, so I shifted it a little bit away from unlikely because it's more, it should be a bit closer to impossible than unlikely itself. Now let's talk about London. Will it rain in London on the 38th of November? Okay, I think that it should be close to being certain, but not really certain, so maybe somewhere here, yeah. So it's likely to rain in November in London. Let's take a look at, you will have something to drink this week. Of course, everybody have to drink something, whether you're drinking water or you are drinking juice or you are drinking anything. You have to drink something within a week, within 7 days. Oh, if you don't drink anything, you're going to die. So obviously, it is very certain, guys. It is very certain that you will definitely drink something this week. Okay, this is the correct place and it is certain or you will die otherwise. Yeah. Okay, let's move on. We have a spinner here. Will this spinner land on the white part of the spinner? This is white, blue. Oh, no, this is not blue because we can talk about this being blue. Maybe this, okay, you can take this to be maybe purple, or this is yellow, this is green. I have 5 colors here, 5 different colors, okay? So for you to land on white, it means that the chance white has is 1 out of 5. And 1 out of 5 to be placed on your probability scale. 1 out of 5 should be somewhere here. I have it on the scale of 4, the one I have here. So out of 5 should be a bit around here, and that is correct. There are 5 sections, only 1 is white. So it's quite unlikely to land on white because there are 4 more other colors that have chances to also be shown. Okay, let's have the next one. This is a dice. Now, when you roll a dice, what is the chance that you get an odd number? Oh, we all know a dice. You can see the diagram of a dice here. You have numbers 1 to 6 on a dice. How many of those numbers are odd numbers? Of course, 3 of them. 1, 3, and 5. So because of that, the other numbers are even numbers, 2, 4, 6 on the dice. So you have 3 even numbers and you have 3 odd numbers. What do you think? It's going to be an even chance because both numbers are equally likely to occur. So therefore, it is equally likely that you get odd as you get even. So this is even chance, and that is correct. Now let's come here and talk about a bag of sweets. If you pull out a blue sweet from this bag, from this particular bag, what is the chance that you're going to pull out a blue sweet? If I look at it, I have a total number of 7 sweets, and the blue ones are actually 5. So 5 out of 7. 5 is very close to 7, so it should be somewhere around here. Exactly, and that is correct. So it's quite likely, as there are more blues than you have whites. So it's quite likely that you pick or you pull out a blue sweet from this bag. Now let's move on. In this bag, the new bag I have here, there are 6 sweets. Some are blue and some are white. What is the chance of picking a white one? Now there's a trick here, guys. Remember in that last example, we were able to see the sweets in the bag. We knew the number of blue sweets and the number of white sweets. But in the case of this bag, guys, we don't know the number of sweets inside. So we can't even say how likely it is or the chance that we have for picking a white one, since we don't even know the number of whites. It is even possible that there's no whites inside this bag. So the answer to their question is we don't know, as we can't see in the bag. Okay, let's pick one out. It is white. Let's put it back in. Now we need to do this lots of times to estimate the chance of picking a white. Let's do it 10 times to start with. The first one is white. Second, white again. Third is blue. Fourth is blue. The fifth is white. The sixth is white again. The seventh is blue. The eighth is blue. The ninth is white. And the 10th is white again. So you see we have, doing it 10 times, we're able to pick out 6 white and 4 blues. What do you think the chance of choosing a white sweet is now? Since we know the number now after picking it 10 times, we have more whites being picked than blue. So we should have a bit certain, yeah, somewhere here, it could be here. So far you are not picking impossible because we've been able to pick out white sweet. Anywhere you put it may be true. It's even certain because we know there are white sweets, but it cannot be impossible, okay? If you put it on impossible, it will tell you that can be possible. We got some white sweets there, so it can be any other place apart from impossible. Now, let's see what's in the bag, guys. Wow, wow. Can you imagine? We have equal number of blue sweets and equal number of white sweets. Did you expect that? Well, of course we didn't. We didn't expect that, okay? Things don't always happen the way you expect them to, guys. That is why we talk about probability. So, but the more goals you have, okay, in picking the sweet out and returning and picking again, the better the picture you have on what in the bag. Now, the numbers should even out if we do it more times. That means the more times you do an experiment, you try something out, the better the outcomes that you have. So white outcomes will be getting closer and closer to even out with the blue outcomes. Let's see, we can do a few number of trials. If you try it 100 times, what happens? You see, 66 white, 34 blue, that's still a bit far. Let's try it 500 times. 220, 280, that's quite close. And you see that they are closing up now. Let's try it 1,000 times. 537, 463. They are closing up. So the more you keep going, these two events will close up their outcomes. All right, so that is that. Remember, we are introducing probability, so let's keep going. Ethan is going to take a sweet from each bag. Match the pictures to the statements. Okay, these are the bags. We have bags A, B, C, D, E, and we can see the sweets inside them. It is impossible that Ethan will take a white sweet from bag what? Is it bag A, bag B, bag C, bag D, or bag E? Of course, if it is impossible for Ethan to pick a white sweet, it means there is no white sweet in that bag. So I think we are going for bag D. It's because you don't have a white sweet in that bag. That is why it is impossible for Ethan to pick a white sweet. Next one. It is likely that Ethan will take a white sweet from the bag. Likely means it is very close to certainty. Okay? And so that means I'm going to have to go for the bag that has more white sweets. Yes. So this one right here, bag B, has more white sweets than blue. So definitely I would say that bag B is more likely for him to pick the white sweet. The last one, it is an even chance that Ethan will take a white sweet from the bag. I'm looking for the bag that has equal number of white and blue sweets to get an equal chance or an even chance. That is bag C, 3 blue, 3 white. So this should be for bag C. Let's mark it. All correct. Well done, guys. Let's move on. Now, here is another bag of sweets. Add or remove sweets to make these statements true. Now, our first statement here is saying that it is equally likely that I pick a white as a blue. Now, we know that if it is equally likely, it means that I must have equal number of whites and equal number of blue sweets for it to be equally likely. I think what I'm going to have to do is to come here to the blue and then add one more blue sweet so that, I'm to add 2 more blue sweets to achieve that, or I remove 2 white sweets so that I can have equal number of blue sweets and white sweets. So which one do you want to go for? Should we remove or we should add? I think I'm going to add 2 more to my blue sweets. So let's mark it. We are correct. There are equal number of white and blue. So if I probably pick another question, let's take a look at this. It is impossible to pick a white. If it is impossible to pick a white, guys, that means that we shouldn't have any white sweets inside this bag. So I'm going to come to white, remove the white, remove the white, remove the white. So in this case, it is impossible to pick a white. Definitely we are correct. Let's take one more question before we move on. It is very likely to get a white. If it is very likely, can you see that the question didn't say it is likely. It said it is very likely. So that means we need a lot of white sweets inside this bag to make that happen. Or we need very small amount of blue sweets to make this happen. So which one should we do? Let's reduce the blue. No. There's the blue we should remove. Let's remove the blue. Let me just remove in fact, remove all of the blues and keep 1. Then I know it is very likely that I pick a white. And mark it. Yes, they are nearly all white. Thank you, guys. I believe you understand that. We proceed. Now, here we have rules for a particular game. The rules here is that you are playing against the computer. Roll the dice. The dice can land in 2 ways. Either it lands on a 5 or not on a 5. When we say not on a 5, it means it lands on the other numbers. Now, if it lands on a 5, then you score a point. That is you. Otherwise, the computer scores a point. The first person to get to 5 points wins the game. Okay, guys, let's play the game. I'm going to roll the dice here. Roll. It gives me a 3. That is not a 5. Oh, computer wins. Let me roll again. 4. That is not a 5. Computer wins again. Let me roll again. 5. I win. Yeah. I win this time around. Okay, let me roll again. 5 again. I win. Let me roll again. 6. Oh, I didn't win. Computer wins this time around. Let me roll again. 6. Computer wins. Let me roll again. 2. Oh, computer wins. Oh, I lost this game to the computer. Better luck next time to us. But if you take a look at what is going on there, computer was having almost more scores than I. What is going on? Why? Let me play again. Let me just play again. Let me play the game again. We're going to roll. 5, I win. I should win this game. What do I have? 5 again, I win. Oh, no. Okay, it was not. Okay, I haven't actually. Okay, let me roll again. Okay, it was computer. Computer again. Computer winning again. I think there's something going on here. Okay, I win. Let me roll again. 2, computer win again. Let me roll again. I should win now. Computer wins again. Man, I don't think this game is good. I'm just going to continue. Okay, on the last page, we played a game with a dice. If you rolled a 5, you get a point. If you didn't, the computer gets a point. Was this game fair? Of course, guys. The game wasn't fair at all. It wasn't fair. The computer was just winning all the games. Exactly. There was only one way for me to win, okay? And that is a 5. But the computer had more ways to win than I did. So I was very unlikely to win. The game was definitely unfair. Can you imagine? Okay, how could I make this game to become a fair game? One of the ways is I could say odds, I win. Evens, the computer wins. Now we have equal chances. Now this is a fair game. There's another way. I could say 3 or less, I win, or you win. 4 or more, the computer wins. So we still have 3 outcomes, okay? So that's still fair. So definitely, there are other ways too, guys, for us to make the rules to make the game very fair. For each of these fair games, there are an equal number of ways to win and to lose, and that makes it very fair. Each player has an equal chance of winning. So see if you can think of another game with a dice which is fair or one which is unfair. So I'll expect you guys to send me the answer that you are able to come up with of another game with a dice which is fair. Finally, for today's class, let us look at dice simulation to show us what happens when we roll the dice. Now, if I press the play button, it's going to roll the dice for me 20 times. The table you are looking at right here is showing us that on the dice, we have 1, 2, 3, 4, 5, 6. Those are the numbers on the dice. The frequency here is going to tell us the number of times each of these numbers on the dice appeared, okay, or occurred when we rolled the dice. So we're going to do it 20 times. Let's hit play. 2 once, 4 once, 6 once, 4 twice, 1 once, 3 once, 6 twice, 5 once, 2 again, 3 again, 5 again, 1 again, 6 again, 4 again, 6 again, okay, 2 again, 5 again, 6 again, 3 again, 4 again, okay. Are we done with the 20 times? 6, 4, 10, okay, 5, 5, 10. We are done. So out of the 20 times that we roll the dice, you can obviously see right here that these are the frequencies showing the number of times each of these numbers actually appeared. 1 appeared twice, 2 appeared 3 times, 3 appeared 3 times, 4 appeared 4 times, 5 appeared 3 times, and 6 appeared 5 times. This is very important for us to learn so that we understand our dice simulation. Look at the frequencies of the scores. Is this a fair dice? How will 6 come out 5 times? Okay, that's a lot of times than others. All right. It is hard to tell actually if the number of rows is low. The only time we are able to, okay, so take note of that, guys. If you do not do a lot of simulation, I mean a lot of rolling of the dice, okay? Let me put it this way. The total number of trials, it has to be high for you to be able to estimate whether, the dice is fair or not. So if you don't do so much trials, you won't be able to say. It will be hard to tell. So lower number of trials, okay, will make us, or will make it hard to tell, okay, if the dice is actually a fair dice. But if you do a lot of trials, so let's fast forward to the result for 1,000 rows. Look at what we have here. 98, 175, 173, 171, 175. All these numbers from 2 to 5, very close numbers. That is very nice, okay? 98 is not, 208 is far off. Is this a fair dice? After 1,000 rows, we can see that the number 6 comes up more often than the rest, and the number 1 comes up less often than the rest. Obviously, this could just be chance, but after 1,000 rows, we would expect the result to be roughly even between each number. And it looks like this dice is not fair. So what you are looking out for a fair dice, okay, is to make sure that all the frequencies, all right, they are all very close to each other. 1, and there is no frequency that is far away from the others. Okay, they all must be close to each other. Then it is fair. This one here is not fair. So 3 things we've picked from here. If there are certain frequencies that are too far from the rest that are close to each other, it's not fair. If the total number of rows or the total number of times it was done is so low, it will be hard for us to tell. And definitely, if all the frequencies are close to each other, none of the numbers are far from each other, then such an event would be fair. Such dice would be fair. Okay, I think that explains it all for today's class. For the introduction of probability, we have learned a lot today about the probability scale, the even chances, the certainty, the uncertainty, which is also called the impossible. We've also learned about the dice, okay? We've learned about the dice as well to know whether a dice is fair or is unfair or it is hard to tell. So guys, take a look at your Edmodo page. Your assignment has been dropped for this particular lesson. So go to your Edmodo, you will see the assignment right there. You'll be also sent to myimath.com to pick up your assignment. Take note that this lesson was actually picked from MyIMath, which is a platform that we are using in school at the moment. Every of our students have their login details into MyIMath, so you need to go there and do your assignments. Thank you, guys. We're going to see you in the next class for the next series of this topic. Thank you, and thank you very much. I'll see you in the next class, guys. Thank you so much. Bye for now.